right, hello everyone. This is Melody Rondeau, and I'm going to be walking us through the rest of our lesson on 10.2. So we left off, we were doing a significance test for a difference in means. We were talking about the Chips Ahoy cookies and the Great Value cookies, and we had done the do step on our calculators, and we just needed to do the conclude. So we're going to wrap it up here with our conclude step. So we found a p-value from the calculator. So I'm going to put p-value of 0.78, and we are going to be comparing that to our alpha, which is 0.05. That's the alpha. And we're looking for, again, whether it's greater than or less than. And so hopefully you guys can see there that 0.78 is definitely greater than 0.05. So when it is greater than, we are going to fail to reject, because the greater than means it's pretty likely that this would happen just by chance. That's given that the null hypothesis is true. All right, so we're going to say we fail to reject H naught. We do not have, sorry, get my spelling here. We do not have convincing evidence There we go. We do not have convincing evidence of what? Well, if we go back to our state, we were trying to show that there was a difference, that the difference between the Chips Ahoy and the Great Value cookies in terms of chocolate chips was greater for the Chips Ahoy than the Great Value. So we do not have convincing evidence that Chips Ahoy cookies have more chocolate chips per cookie than our Great Value cookies. All right, so that should finish off that example. So walking through that significance test. Let's see I said that example, but we still have part B. So here we go with part B. Interpret the p-value that you got in the context of this study. This, by the way, was a question on the Chapter 9 test, which was our significance test. That's funny, significance test. Where we did pretty much all the significance tests, and we had a lot of people not do too hot on this question, interpreting the p-value. So we start, when we interpret the p-value, with the assumption that the null hypothesis is true. So in this case, we would basically say that in words: if the true mean number of chocolate chips per cookie for Chips Ahoy and Great Value cookies is the same. So that's basically our null, that there's no difference, they're the same. There we go. Okay, so we start by assuming the null hypothesis is true, assuming that the mean number of chocolate chips is the same for the two brands. Then we would say the probability, because remember, p-value is a probability. The probability, and here's where we're going to say basically the probability of getting the same result in a statistical study again. So in this result, in this study, we had the different or we had a mean number of chocolate chips for the Chips Ahoy cookies, and we had a mean number of chocolate chips per cookie for the Great Value cookies. So basically, our probability is that we would come up with this same result again. I'm going to say that in terms of the difference in means, because it could be that we get a different set of numbers, but we're looking at the overall, the difference in the two means. So I would say something like this: the probability of getting a mean difference of, and let's see what our mean difference was. Let's go back for a second. Looks like our mean difference, I don't think I have it here in our notes. Whoopsie. Sorry about that. We would have to look back at the calculator and look at the two means and compare them. And so, yeah, I'm sorry we don't have it here handy, but we would have pulled that up on our notes. It might be in our previous lesson where we did the confidence interval. I have it in my notes as the mean difference of -1, but I'm not sure that I did it the same way. Yeah, it looks like it's the same. Oh, look, I stole it and wrote notes to help us out. There you go, I have the notes. So from the calculator, our x bar 1 minus x bar 2, here's what I stole from the calculator. The mean for x bar 1, which is our Chips Ahoy, is 18.4. And the mean for the Great Value cookies is 19.4. And that, of course, then equals the -1 I was just talking about. So just a quick reference, this is based on our null hypothesis, which was that the mean of Chips Ahoy minus the mean of the Great Value is equal to 0. So that's the order. So this again is the 1s and this is the 2s. Okay, so that's where I get the -1. Sorry. Woo! Okay, so the probability of getting a mean difference that matches what we got in our experiment, in our little sample here, or more extreme. So we're going to say, since we were hoping that it would be more, so our alternative, I'm going to just quote our alternative here to help us out. Mean chocolate chip, Chips Ahoy minus the mean of the Great Value is greater than 0. So that greater than is our alternative. So I'm going to say the probability of getting a mean difference of -1 or more, because I'm going in the same direction as my alternative, is approximately, and here's where I say what my p-value was. My p-value was 0.78. So there you go. Again, that process, we have it in our notes in a previous place, is basically, and you don't have to write this down, but I'm just going to list it for us. It was assume the null hypothesis is true in context. This is what we did to achieve this answer. Then the probability, wow, having trouble writing here. The probability can't spell probability. Wow. Probability of getting the same result. So our result was that the mean difference was -1. But getting the same result, or, wow, can't spell or, or more or less. So this depends on the alternative hypothesis, is approximately, and then whatever that is our p-value. So that's a quick review of how to come up with that statement. It's essentially that little sentence frame. But again, if you look back in a previous lesson, I would guess it would be in chapter 9, probably 9.2 or 9, probably 9 point, actually might even be 9.1. We went through that process of explaining how to interpret the p-value. All right, on the calculator. We had already talked about this, but just in case, here are the steps. So take a minute and write those down to get to the 2-sample t-test. We actually did this already on our calculator. And then, yes, of course, we're going to be choosing between data and statistics as our input method. We saw that when we did this problem. If we choose data, we must have already input the data into the lists in the spreadsheet. And we saw that because we ran into that exact problem. And then the calculator asks if the data are pooled, and we're going to say no. So these two things are what you are writing down. You don't have to write down the other things. The formula for the 2-sample t-statistic for a test about mu1 minus mu2 often leads to calculation errors by students. As a result, we recommend using the calculator's 2-sample t-test feature to perform calculations so we don't make a mistake. All right. I think we just read that. Okay, so on the AP exam, we're going to make sure that we name the procedure. So we're going to say a 2-sample t-test, and you can steal that from your calculator. I would strongly encourage you, if you're not sure what to write, to steal it from the calculator. That's the first thing. And then we would report the following things in our do step. Since we're using the calculator, we're going to make sure to stay the test statistic is t equals. It's basically what you have on your calculator when it spits it back the answer to you. The p-value and the degrees of freedom. So those are the 3 things that we need to make sure that we report when we say on the calculator for this type of test. All right, with that, we're going to go into our last example for this lesson. Example, oh, I lied. We have example 3 as well. Okay, example 2. And here goes. I'm not sure if you guys have the question part in your notes. How quickly do synthetic fabrics such as polyester decay in landfills? Maybe, maybe not. I will read this for us. A researcher buried polyester strips in the soil for different lengths of time, then dug up the strips and measured the force required to break them. Breaking strength is easy to measure and is a good indicator of decay. Lower strength means the fabric has decayed. For one part of the study, the research buried 10 strips of polyester fabric in well-drained soil in the summer. The strips were randomly assigned to 2 groups. 5 of them were buried for 2 weeks, and the other 5 were buried for 16 weeks. If we assume the breaking strength for polyester is normally distributed for both 2 weeks and 16 weeks, do these data give convincing evidence that the polyester decays more in 16 weeks than in 2 weeks? All right. So let's get started with our state step. Here we go. We're going to state. We want to test. The hypotheses, and here's where we get to say them. Actually, I don't want a colon yet. The hypotheses that I'm going to say are null hypothesis. And I would ask you if I was there what our null hypothesis is, but it's basically based on the situation. We're trying to show if there's evidence that something decays more than the other. So our null is that it doesn't, that it's basically the same. So I'm going to do M1 minus M2 equals 0. When I set up my alternative, and I'm going to make sure to define these M1 and M2 business. Oh, we already have them set as group 1 and group 2. I didn't see that in our little notes there. Okay, cool. All right, so this one is that we are saying that we want to know if there's convincing evidence that there is more decay in 16 weeks than 2 weeks. Okay, so if there is more decay, lower strength means the fabric has decayed. So this is going to be an important thing. Back up in our problem, it says lower strength means the fabric has decayed. So we are testing, let's see if the strips are randomly assigned Sorry, I have to read through this, guys, just to make sense of it, just like you guys. Okay, so lower strength is how much it takes to break them. Okay, so our mean here in pounds is pounds of strength. So we are expecting the 16 weeks to be a smaller number. So again, this basically is 2 weeks, and this one would be my 16 weeks. And we expect the 16 to be smaller. That's what we would hope. So we would have big minus small, which means this is going to be greater than 0. Sorry, all that work just to make sure I got my greater than in the correct direction. Hopefully that made sense to you guys. Apologize for that lengthy process there. Okay, now that we have those, we do have to define what our variables are. And I kind of have it right there, but I'm going to say where mu1 equals the true mean breaking strength and this is going to be in pounds for polyester after 2 weeks. And of course, because I'm super lazy and hopefully you guys will join me in this, I'm going to basically say repeat, 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 all the way across until I get to here after 16 weeks. All right, so now the last thing, we're missing one more thing for our state step. We said we want to test hypotheses. We said the hypotheses. We have now listed out our definitions. The last thing that we need to do is make sure to include our significance level. And so I'm going to say we weren't given one, so we're going to default to at alpha equals 0.05 significance level. Cool. Then let's get into our plan. Our plan is to do a perform a 2 sample, and is it T or Z? Hopefully we know if we're doing means it is a t-test, and I can't spell test, I missed a letter there. It is a t-test if we are doing means. All right, and then we have to check our conditions. The first one we do is random. Did it say random? And the answer to that is yes. Somewhere in there it said random. I believe it was randomly assigned. The strips of polyester are randomly assigned to how long they get left under the ground. So we can't just say, oh, this fabric was better than this one, because we're randomly choosing ones. There we go. All right, the next we would do is our 10% condition. So 10%. And remember, we would need to meet this for both populations here. So the overall thing, though, is we're talking about polyester strips. So polyester in general. And so this one, for our 10% condition, we actually don't really have a condition to check, because we would say this is essentially infinite. Population, I mean, yes, there is a limit to how much polyester there is in the world. However, essentially we could continue to make polyester as long as we have the resources. So we're going to assume that it's basically essentially an infinite population, so we don't have to worry about the 10% condition. In other words, we're not going to oversample or overuse our polyester. We'll be fine. Okay, so we're good there. So we have random 10%, and then this is mean, so we're going to check normal condition. And the first one we check with the normal, of course, is the population normal. And this one, they actually told us it's normally distributed, people. They actually said yes. So here we are, yes, good to go. All right, so now we have state, we have plan, we are ready for the do, and I'm going to switch over screens just because I do not have, why does that look funny? Oh, sorry, just me. Okay, I don't have enough room on my screen. Hopefully you guys are fitting this in on yours. Let's go to the do step. Sorry, I'm just looking at my notes for a second. Okay, going to our do step on the calculator. So on this one, since we are given the mean and standard deviation, that we should know is statistics. So I'm going to actually pop over to the calculator here for a second. Let's see. Keep that. Let me get to our calculator. There we go. All right, so I'm going to go ahead and go to a calculate page here. And when I go menu, stats, I'm looking for stats tests. We are looking for a 2-sample t-test. And this time I'm going to be using stats because I don't have the actual data values. I have the mean and standard deviation, which are statistics. So for my x1, X bar 1, my first group, the mean, let's see, I'm looking at my notes, it looks like 123.8. My standard deviation was 4.6. The number in my sample, let's see, was 5. For x2, I had 116.4. And then my standard deviation was 16.09. And then the number in my sample was 5. And then my alternative, I'm expecting that mu1 is greater than mu2, that the 16 weeks is more than the original or the lesser 2 weeks. And then no, we are not pulling our data, and I'm going to hit OK, and it's going to give me lots of information. I want to make sure to include in my stuff, I'm going to say make sure to include the t-value, my t-statistic, my p-value, and my degrees of freedom. So on this, hopefully we can see that. That's right up here. So I want to make sure to include basically these 3 things right here. My t-value, my t-statistic, my p-value, and my degrees of freedom. All right, so I'm going to pop over back to the notes. And I think I did some rounding here. Looks like I have, or I didn't round very well. Wow. Okay. I'll do my best to round. Here we go. So back to our notes. Okay. I lost my pen. Hold on. Okay, there we go. Okay, so I'm going to say on the calculator, and here's what I came up with. Again, we need the t statistic. So our t was 0.9888. I think there's 3 8s. And then our p-value was 0.186. That's a rounded answer. Hopefully I rounded correctly. I don't have the original in front of me. My degrees of freedom, 4.65. Again, rounded answer. All right, once I have those from my calculator, then I'm going to go to my conclude step and wrap it up. Let's see what we get. Conclude. All right, so I have my p-value, which we got was 0.186. Then I'm comparing that to 0.05, which is my alpha, and that is greater than, which means we fail to reject. the null hypothesis. We do not have convincing evidence of something. We do not have convincing evidence that polyester decays more in 16 weeks than in 2 weeks. All right, so that finishes that example. You guys might need to pause, but I'm going to go ahead and go forward to our last one. This one, independent samples versus paired data. So in each of the following settings, we're going to decide whether we should use paired T procedures. We talked about that back at the end of chapter 9, or two sample T procedures to perform inference. So, and we're going to explain our choice. So part A says to test where characteristics of two tire brands, A and B, one brand A tire is mounted on one side of each car in the rear, while a brand B tire is mounted on the other side. Which side gets which brand is determined by flipping a coin. So that's our random piece there. So is this a paired T procedure or is it a two sample? So are we doing two completely independent samples, or are we doing kind of two samples on the same individual? Since we're using the same car for this one is going to be paired T procedures. This is a matched pairs experiment with two treatments, brand A and brand B, being randomly assigned to the rear pair of wheels on each car. So this part in blue is what you're going to write down for your answer there. And then for part B, can listening to music while working increase productivity? 20 factory workers agree to take part in a study to investigate this question. Researchers randomly assign 10 workers to do a repetitive task while listening to music, and the other 10 workers to do a task in silence. So this one, because we have two separate groups that are doing two separate things, this one we would use our two sample T procedures. So the data are being produced using two distinct groups of workers in a randomized experiment. So again, this is what you are writing down for your answer. And once you have that written down, that does conclude these notes. So check those success criteria. I can perform a significance test for a difference between two means, and I can determine when to use paired T procedures versus two sample T procedures. That is it for that lesson. We'll catch up with you guys later.